Hello students, in the last lecture about the Nernst equation and Nernst equation how applicable for single electrode potential and how to determine the cell potential by using the Nernst equation that we have studied. Now today we are to study type of electrodes and some electrodes in detail we have to study. So first of all, you have to remember that an electrode is also called as half cell. So what is half cell? Half cell means a metal rod is placed in a solution containing of its own ion, that is called as electrode, that is called as half cell. A metal is directly contact with a solution of its own ions. It is called as the electrode, or it is also known as half cell. And now these half cells or electrodes are of different types, and that type of electrodes here we are to study. First one type of electrode, it is metal ion electrode, metal ion electrode. So what is a metal ion electrode? When in an electrode a metal is placed in its solution, a metal is placed in a solution of its own ions, that is called as metal ion electrode. A metal is directly contact with a solution containing of its own ion. That electrode is called as metal ion electrode. For example, you see here a copper is placed in a solution containing of its copper ions, that is the copper electrode or copper half cell. A silver is placed in a solution containing of its own ion, that is the silver ions. Or zinc is placed in a solution containing of its own ion, that is the zinc ion. Or nickel is placed in a solution containing nickel plus 2 ions, that is of its own ions, that is in aqueous medium. So all these are examples of metal ion electrode. So metal ion electrode means electrode in which a metal is in contact with a solution containing of its own ions, that is called as metal ion electrodes. Then see second type of electrode, that is the indicator electrodes. So what are the indicator electrode? These are the electrodes in which potential of electrode depends on concentration of particular ions present in that electrode, depends on the concentration of particular ions present in that solution or electrolyte. So that type of electrodes are called as indicator electrodes. For example, here indicator electrode, that is the zinc is placed in a solution containing of zinc ions. The potential developed at zinc electrode depends upon the concentration of zinc plus 2 ions. So it is nothing but the indicator electrode. It is indicator electrode. As well as ninhydrin electrode. Ninhydrin is a substance. Ninhydrin electrode is also indicator electrode, means metal ion electrode as well as indicator electrode are almost same. That is the concentration of particular ions decides the potential of that electrode. So it is the indicator electrode. Now see, next type of electrodes are gas electrodes. In this type of electrodes, pure and dry gas is passed through solution, passed through a solution containing of its own ions at 1 atmospheric pressure and 298 Kelvin temperature. So that electrode is called as the gas electrode. In case of gas electrode, pure and dry gas is bubbled around the platinized platinum foil or the plate placed in a solution containing of ions of that gas, containing of its own ion. That type of electrodes are called as the gas electrodes. That is known as the gas electrode. And see examples of gas electrode. That is the hydrogen gas is bubbled around the platinized platinum foil containing solution, that is the H plus ion. As well as here we have to take platinum, oxygen gas is bubbled and here it contains the OH minus ions, that is the oxygen gas electrode. Here platinum, chlorine gas is bubbled around that platinized platinum foil and here Cl minus ions present in the solution. So that is called as, they are known as the gas electrode. In case of gas electrode, pure and dry gas is bubbled around the platinized platinum foil through a solution containing of its own ion. So that electrodes are called as the gas electrodes. They are known as the gas electrode. Then here see, next type of electrodes are redox electrodes. Next type of electrodes are redox electrode. So what are the redox electrode? In this type of electrodes, in this type of electrode, a inert electrode, inert metal like platinum is placed in a solution containing both that is the reduced as well as oxidized state of that metal ions, that type of electrodes are called as the redox electrode. You imagine, imagination is important than knowledge. So when you take a beaker or a half cell, in that half cell you have to take a solution which contains both the state of metal ion, reduced state as well as the oxidized state, and a inert platinum electrode is placed in that solution. Then such electrodes are known as the redox electrode. Such electrons are called as the redox electrode. See some examples of redox electrode. That is nothing but, here what, that is the platinum is placed in a solution containing what, that is the Fe2 plus ions and Fe3 plus ion. Here see, platinum is placed in a solution containing Fe plus 3 reduces to Fe2 plus and Fe plus 2 oxidizes to Fe3 plus. Then next one example, that is platinum is placed in Cu plus and Cu2 plus. That is the cuprous and cupric, ferrous, ferric, ferrous, ferric. Then Sn2 plus, Sn4 plus, and platinum electrode is placed in it, stannous, tannic. So both oxidized and reduced state are present in the same solution, and in such solution inert platinum electrode is placed, and that type of electrodes are called as the redox electrodes. They are known as the redox electrodes. Now next type of electrodes here we have to study, that is the reference electrodes. See what are the reference electrodes, and then we have to study types of reference electrode or some reference electrodes in detail. Reference electrodes are the electrodes. These are the electrodes whose potential is already known. It is arbitrarily fixed. It is already known or arbitrarily fixed. That electrodes are called as the reference electrode. Why these electrodes are called as reference electrode? Because these electrodes are used to find the potential of another unknown electrode. Potential of other electrodes are decided by coupling that other electrode with these electrodes, because its potential is already known, its potential is already fixed, and therefore potential of other electrode is determined by determining the cell of that electrode and this reference electrode. So these electrodes are used to determine potential of some unknown electrode or other electrode. Therefore they are called as the reference electrode. They are known as the reference electrode. For example, that is the standard hydrogen electrode. Standard hydrogen electrode is reference electrode, and second example of this is calomel electrode. Calomel electrode. So these are the various type of electrode. Potential of standard hydrogen electrode is already known. Potential of standard hydrogen electrode is arbitrarily fixed. So therefore it is a reference electrode. As well as potential of calomel electrode is known at different concentration of KCl. So its potential is already known, its potential is already fixed, and therefore it is nothing but the reference electrode. So these are the various type of electrode, that is metal ion electrode, indicator electrode whose potential depends upon the concentration of particular ions present in that electrolyte or electrode. Gas electrodes are the electrodes in which a pure and dry gas is bubbled around the platinized platinum foil, platinized platinum plate in a solution containing of its own ion. Then redox electrodes are an inert metal. Inert electrode is placed in a solution which contains the both oxidized and reduced state of that metal ion. That is called as the redox electrode. And last and fifth type of electrodes are reference electrode. Reference electrodes are the electrode whose potential is already known, whose potential is arbitrarily fixed. That is called as the reference electrode. Two best examples of reference electrodes are standard hydrogen electrode and calomel electrode. Now we have to study in detail about the standard hydrogen electrode. So see about the standard hydrogen electrode, means construction of standard hydrogen electrode, working of standard hydrogen electrode, representation of standard hydrogen electrode, as well as difficulties in the setup of standard hydrogen electrode, and we have to study also applications of the standard hydrogen electrode. Applications of standard hydrogen electrode. So see, standard hydrogen electrode. Standard hydrogen electrode. What is standard hydrogen electrode? It is abbreviated as SHE, that is standard hydrogen electrode. Now in this standard hydrogen electrode, pure and dry hydrogen gas at 1 atmospheric pressure or 1 baric pressure and at 298 Kelvin temperature is passed through solution containing 1 molar H plus ion, and this gas is passed in that solution around the platinized platinum plate, around the platinized platinum foil. So that is nothing but the standard hydrogen electrode. Pure and dry hydrogen gas is bubbled around the platinized platinum foil at 1 baric pressure and 298 Kelvin temperature through a solution containing 1 molar concentration of H plus ion. Here all conditions are standard. Pressure 1 atmosphere, temperature 298 Kelvin, and concentration is also unit activity, that is 1 molar concentration. So electrode is standard hydrogen electrode. You see the second one point, that is construction of standard hydrogen electrode. Construction of standard hydrogen electrode. How standard hydrogen electrode is constructed, you here see. It consists of this vessel. See carefully. It consists of a vessel. In this vessel, 1 molar solution of HCl is taken, or 1 molar solution containing H plus ion, that is the 1 molar. Concentration of H plus ion is 1 molar, this vessel. Now, you have to take a tube, glass tube. This is a glass tube. In this glass tube, that is the copper wire runs, and this copper wire here dipped in liquid mercury. इथे हे कॉपर वायर कशामध्ये डीप केलेला आहे, लिक्विड मर्क्युरी. नाउ at the bottom of this liquid mercury, platinum wire is placed here. Platinum wire is fixed, and then this platinum wire is connected to platinized platinum foil or platinized platinum plate. Okay, once again, this is a narrow elongated glass tube. In this narrow elongated glass tube, copper wire runs. That copper wire at the bottom is dipped in liquid mercury. Then at the bottom a platinum wire is fixed. This platinum wire is connected to platinized platinum foil. Then this is placed in outer glass jacket. This is the outer glass jacket. To this outer glass jacket there is one inlet. For what? That is, inlet is for pure and dry H2 gas. Inlet is for pure and dry H2 gas, to pass the pure and dry H2 gas, and there are small holes at the bottom to this outer glass jacket to escape the excess of hydrogen gas. म्हणजे एक्स्ट्राचा हायड्रोजन गॅस तिथून इस्केप होण्यासाठी इथे स्मॉल होल्स आहेत त्याला. ओके, दिस होल असेंबली then placed in this solution containing 1 molar H plus ion. This overall, or this is called as the standard hydrogen electrode. It is known as the standard hydrogen electrode. Now see, standard hydrogen electrode, how represented? Representation of standard hydrogen electrode. Now you see, first of all we have used what, that is the platinum wire. This is the platinized platinum foil. That platinum, around this platinized platinum foil, what is bubbled? Hydrogen gas is bubbled. Now this hydrogen gas is bubbled through a solution containing 1 molar solution of H plus ion, and this is the representation of standard hydrogen electrode. So don't forget, inert platinum electrode. Around this inert platinum electrode, hydrogen gas is bubbled. Hydrogen gas is bubbled at 1 atmospheric pressure or 1 baric pressure. Then this is directly contact with what, that is the solution containing H plus ion of unit activity or 1 molar concentration. So here H2 gas is bubbled around platinized platinum foil, but that is through the solution of 1 molar concentration of H plus ion. Okay, that is nothing but the representation of standard hydrogen electrode. Now we have to study working of standard hydrogen electrode. Working of standard hydrogen electrode. This electrode is a reversible electrode. Standard hydrogen electrode is reversible electrode, means its working depends upon the electrode with which it is connected or coupled in a galvanic cell. यानी क्या, ए इलेक्ट्रोड दूसरे कौन से इलेक्ट्रोड के साथ कनेक्ट किया है गैल्वेनिक सेल कंस्ट्रक्शन में. अगर वो दूसरे इलेक्ट्रोड पे ऑक्सीडेशन रिएक्शन होती है तो स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड पे रिडक्शन रिएक्शन होगी. और वो जो दूसरा इलेक्ट्रोड इसके साथ कनेक्ट किया है सेल में, गैल्वेनिक सेल में, अगर वो दूसरे इलेक्ट्रोड पे रिडक्शन रिएक्शन होती है, रिडक्शन होता है, तो इस इलेक्ट्रोड पे ऑक्सीडेशन हो सकता है. यानी कि दिस इलेक्ट्रोड इज रिवर्सिबल इलेक्ट्रोड, मींस बोथ रिडक्शन as well as oxidation reaction can takes place at this electrode, but it depends upon the electrode with which it is coupled in that galvanic cell. So here see, we have to study the reaction working as cathode. Suppose working as cathode, when this electrode behaves cathode, then from solution of this HCl or solution contains the H plus ion will accept the electrons from that platinized platinum foil or that electrode, means this reaction takes place. H plus ions in aqueous medium accept electron and there is formation of half H2 gas as there is gain of electron, so it is reduction reaction. Okay, reduction reaction is take place, and if oxidation takes place at this electrode, then at that time it will behaves anode. It will behaves anode. So gas is passed through this electrolyte or solution. The gas undergoes oxidation in this way. H2 gas passes into solution as H plus ion, loss of electron, reverse reaction is oxidation, and forward reaction is what, that is the reduction. So working of electrode is in both direction. It depends upon the electrode with which it is coupled in that galvanic cell. So as cathode, when it behaves, when it acts, then reduction takes place from solution. H plus ion accept electrons and there is liberation of H2 gas. म्हणजे hydrogen gas is liberated at this electrode. This is nothing but the working of this electrode, electrodic reaction. Here point to be remember that during the working of standard hydrogen electrode, potential developed at this electrode is negligible, and therefore standard reduction potential of hydrogen is taken approximately 0 volt. So its potential is already known. It is arbitrarily fixed, that is the 0 volt, and therefore this is the reference electrode. It is what, that is the reference electrode. This is nothing but the construction of standard hydrogen electrode, then representation of standard hydrogen electrode, and working of standard hydrogen electrode, So you don't forget at this electrode negligible potential is developed. So this electrode has potential taken arbitrarily 0, fixed 0 volt. So it is what that is the standard hydrogen electrode, is a reference electrode. Now I am telling to you difficulties set up in the construction of standard hydrogen electrode. What are the difficulties or limitations of standard hydrogen electrode? It is not easy to construct the platinized platinum foil. एक मेटल दूसरे मेटल के ऊपर डिपॉजिट करना आसान है, मगर सेम मेटल उसके ही ऊपर डिपॉजिट करना डिफिकल्ट है. So idealized platinized platinum foil cannot easily constructed or prepared. That is one of the difficulty. Second difficulty is that it is difficult to maintain the pressure of hydrogen gas 1 atmosphere. 1 atmosphere pressure long time हम create नहीं कर सकते, क्योंकि जैसे जैसे हाइड्रोजन टैंक से यूज होगा वैसे वैसे उसका प्रेशर कम हो जाएगा. सो देयरफॉर इट इज डिफिकल्ट टू गेट द प्योर ड्राई H2 गैस as well as for long time we cannot maintain the 1 atmospheric or baric pressure for hydrogen gas. Next one point, due to bubbling of H2, hydrogen gas is continuously bubbled in that solution. So temperature of solution is changed, and if temperature change, concentration also cannot be kept 1 molar for long time. यानी कि concentration भी हम 1 molar long time constant नहीं रख सकते, क्योंकि हम यहाँ जब हाइड्रोजन गैस यहाँ बबल करते हैं सोल्यूशन में, so due to that bubbling temperature of solution change, temperature of solution increases and therefore volume changes, and if volume changes, concentration of solution also change. Okay, this is also difficulty in the setup of hydrogen. Maximum this material or equipment is made up of glass, therefore it is difficult to set up, handle as well as the transport. These are the difficulties in the setup of hydrogen gas. One more point I would like to tell you, what are the applications of standard hydrogen electrode. Applications of standard hydrogen electrode. One point here you have to remember, standard hydrogen electrode is a primary reference electrode. It is a primary reference electrode. So primary reference electrode because its potential is 0. And what are the values of reduction potential given in reference book, in your textbook of all other electrodes, that all electrode potential are determined by using this electrode as a reference. यानी क्या, बुक में जो भी रेफरेंस, दैट इज द स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड के वैल्यूज अपने बुक में जो दिए हैं अदर इलेक्ट्रोड के, दैट वैल्यूज आर कैलकुलेटेड बाय कपलिंग दैट अदर इलेक्ट्रोड विद द स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड. उस इलेक्ट्रोड को स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड के साथ कपल किया जाता है, उसे गैल्वेनिक सेल बनती है और वो गैल्वेनिक सेल का पोटेंशियल डिटरमाइन करते हैं. अभी मुझे बताओ, इस हाइड्रोजन इलेक्ट्रोड का पोटेंशियल 0 है, यानी कि गैल्वेनिक सेल का जो पोटेंशियल आएगा वही पोटेंशियल अदर इलेक्ट्रोड का होगा. यानी क्या, ऑल अदर इलेक्ट्रोड पोटेंशियल आर डिटरमाइंड बाय यूजिंग द हाइड्रोजन इलेक्ट्रोड एज ए रेफरेंस इलेक्ट्रोड. सो इट इज primary reference electrode, and therefore to determine, to find the reduction potential of other electrodes, there is use of standard hydrogen electrode as a primary reference electrode, as a primary reference electrode, there is use of what, that is the standard hydrogen electrode to determine, to find out the values of all other electrode. Reduction potential values of all other electrodes are calculated by using this, what, that is the standard hydrogen electrode as a reference electrode. That is nothing but the application. हमारे बुक में इस इलेक्ट्रोकेमिस्ट्री चैप्टर में लास्ट पेज पे जो वैल्यू दिए हैं, all that values of standard reduction potential of all other electrode are determined by using the standard hydrogen electrode as a reference electrode. So this is about the type of electrodes and reference electrode. One of the reference electrode we have studied in detail, that is the standard hydrogen electrode. Okay.